I'm John Beck, the Executive Director for the National Center for Autonomous Technologies. I want to welcome everyone here today. I think most of the people are familiar with the different participants on the line today, as it's really a core group of the NCAT team. But I know we do have a couple of additional participants who are plugging in who have very closely related projects to some of the different work that we're looking to achieve through the NCAT initiatives right now, specifically focused on distance delivery and really transforming the classroom and incorporating some of the different distance options that are out there. So I want to extend that welcome and greeting to those new participants in the team. Right off the bat, as Zach said, we are recording this session. So we can use this as a national resource to help others out as they look at the integration of new technology and the distance delivery concepts. So this, the webinar we're doing today is really an extension of a lot of the activity that the team has been engaged in over the last month. Fast and furious again on just new ideas as we look at some of the challenging environments we're dealing with and how to transform our educational delivery methods in this distance environment that we're facing. I think one of the big benefits to the team here is some of the challenges that we're looking to address over the next 4-month period. Really, the summer months are a big ramp up for STEM engagement, student competitions, educator workshops, and some of the different environments where we really have a lot of flexibility to experiment, try new things, and look at what's possible with some of the distance delivery tools. So back on April 13th, we had a initial presentation, which was a high-level overview of all things distance delivery, from virtual reality, augmented reality, video capture, content packaging, and different distance platforms like Zoom and Teams. Following that, we had a great presentation 2 weeks ago on April 21st from Mark Gill, the one of the senior partners for the NCAT Center and the director at the St. Cloud State Visualization Lab. He presented with Alan Schrock and did a phenomenal job of looking at collaborative environments using virtual reality and what's possible there. And I know we've got some follow-up do-outs as far as fielding some of the questions. I know there's a lot of very positive feedback and inquiries into VR equipment, price points, different capabilities, how to think about this for meeting the needs of STEM camps versus educator workshops versus the classroom. And we've got a team working to put a white paper together to kind of help field some of those questions, and that'll be out sometime soon. And then today's presentation, we have Kapil Madathil from Clemson University with the Center for Workforce Development, specifically with the Center for Aviation and Automotive Technology Education using virtual e-schools, the CA2VES program. They have been a funded NSF center for more than 10 years, developing a lot of very critical resources that I think help address different needs for distance education. And they'll be providing a presentation today about their regimented academic process and approaches to how they go about developing that content, the task identification, the development, assessment, and evaluation, and continuous refinement to meet those standards. One of the things that they did just recently, I think probably one of their most recent initiatives, was opened up all of their content at no cost to Part 147 schools across the country. And for those not familiar, Part 147 is the Federal Aviation Administration standard for training aviation maintenance technicians, and their curriculum has really helped to support the current environment for distance delivery. And I'm looking forward to hearing the presentation today, thinking about the different ideas to move forward on a lot of the different fronts for the partners, and just driving new innovation and using the great work that they've been developing over the last decade to answer the needs of today. So I'm looking forward to kind of that pairing. And I'm going to do a quick plug as far as another activity that's taking place today, and that's the NSF showcase, or the STEM for All showcase. We've got a link up on the screen. I think we'll get that information into the chat box, but NCAT had a presentation that went into the STEM for All showcase today. You can check it out there. There's a public voting and comment section. So I'm throwing that out there for just something recent that's taking place. But with that, I'm not going to take up any more time on the introduction. I'll go ahead and turn it over to Kapil, and I believe we also have Rebecca Hartley, who is the Director of Operations for the CA2VES program, and Jeff Bertrand, who is the Director of Visualization, that are going to be helping to support this. So definitely appreciate the participation here and look forward to the presentation. And with that, Kapil, are you on the line?
Yes. John, can you hear me?
I can hear you.
Great. And again, thank you very much for the wonderful introduction that you gave. Again, I am Kapil Chalil Madathil. I'm a faculty member in the Department of Civil and Industrial Engineering at Clemson University, and I also co-direct the Clemson University Center for Workforce Development along with Dr. Rebecca Hartley. And Dr. Rebecca Hartley is also on the call, and we have got Dr. Jeff Bertrand, who basically manages our virtual reality development team over here at Clemson. So in this particular talk, I would like to talk more about the lessons that we learned creating e-learning applications for more than a decade, right? What are the things that we learned? What are the few takeaways from the experiences that we had creating these e-learning material to support workforce development? So I typically start my lectures or talks apologizing for my thick South Indian accent, right? I'm not sure if it has got better or worse being in South Carolina for more than 2 decades, right? So if there are questions, concerns, please do let me know, and I'd be more than happy to answer those questions, right? So that being said, I would like to move to the next slide. Right, so in today's presentation, I'm going to give a brief background of the work that we have done in CA2VES, some of the lessons that we learned, and some of the challenges, primarily from delivering this kind of content, remotely for people to use in a wide variety of settings as such. So I believe a few months back, I had a conversation with a couple of my collaborators at Microsoft. They are all developing this virtual reality, collaborative virtual reality based environment, primarily to support a wide variety of use cases as such, right? So they said that there are close to around 1 million plus virtual reality simulations that are being built primarily at academic institutions, at companies, and things of that sort. However, if you could take a look at the user acceptance of these kind of technologies, it's very minimal. Only a very few of them are getting used on a day-to-day basis as such, right? And so the question that begs to be answered over here is that what are those factors that leads to enhanced user acceptance of these kind of technologies, right? So that's a very important thing that need to be kept in mind as we develop these kind of technologies to support the learning or the training needs as such, right? So let me give you a brief background about our center and the work that we are doing here at Clemson, right? And so the initial work here at Clemson started here in 1999, where we were looking more in terms of creating virtual reality-based tools to support aircraft visual inspection, right? So aircraft visual inspection is a skill that you would gain over time, meaning you may probably want to inspect quite a lot of aircrafts to understand the different kinds of issues that you have with the system and identify potential ways to mitigate those issues as such, right? So the initial program was funded by NASA, where we were looking more in terms of building virtual reality based environment to support aircraft visual inspection. So in those scenarios, what we did was that we had this entire virtual reality environment, and we embedded quite a lot of defects within this entire environment, and we provided this particular information to the users to understand the characteristics of the different kinds of defects that are happening within an aircraft as such. And then we basically developed quite a lot of tools, online tools to support specialized training. So the very first set of tool was called Assist. Again, it stands for Automated System for Self-Instruction for Specialized Training in Visual Inspection, that was funded by a project from Federal Aviation Administration. And then we had quite a lot of research projects that were funded by NSF and with Lockheed Martin, and we closely worked with Greenville Technical College on that particular project. So over here, the idea was primarily to look at ways whereby you can minimize the time it takes for the students to understand, the different violations, the different defects that are happening within a cargo bay of an aircraft. So what we did for this particular research study was that we basically identified 20 expert inspectors, visual inspectors who have been doing this kind of visual inspection for quite a long time. And then we basically captured their eye gaze, meaning the way how they have been scanning this entire environment, looking for defects as such. And then we created a virtual environment and we provided this particular information as a feed-forward training for the users to tell them about the search pattern that they use, especially when they are scanning such a huge area like a cargo bay as such. And then we generated quite a lot of publications and from this effort, and intellectual property were developed out of it. And again, we identified that when we provided this feed-forward information to the students, they were able to identify that particular search strategy at a better pace, and the learning outcomes associated with this kind of an intervention was significantly high. Then we started working with Stevens Aviation. We had an NSF-funded project whereby we were looking at the efficacy of of haptic technologies, primarily to understand its effect on teaching technicians as well as inspectors on how to do inspections involving borescope, right? So borescope is just like an endoscope whereby you do have a camera and you will insert this entire camera inside the entire engine of an aircraft, and you will look for different defects, the scarrings and things of that sort that you have on the blade, so that you have a non-destructive inspection happening over there, and you could identify the things that are wrong with the blades as such, right? However, a major challenge over there is basically to navigate this camera in such a way that I believe the camera is not broken, and as you navigate through the entire engine, and again that requires quite a lot of fine skills for you to navigate that particular camera through this system as such, right? So again, this particular system simulator was primarily built to provide that kind of a feedback for the students. That way the students could operate these things well in advance and identify the kind of skills that they need to navigate throughout this entire engine as such. So this was also a research project, primarily focusing more in terms of non-destructive testing. And then in 2009, we received the NSF ATE funding primarily to build a regional center for automotive and aviation training using virtual e-schools, and we created quite a lot of materials as a part of that particular effort. And we'll talk about the key deliverables that came out of that effort in a couple of slides. Then we were part of quite a lot of the TACT grants that were provided by the Department of Labor. We partnered with multiple technical colleges to build virtual reality and online learning components to support some of their objectives. More recently, we do have a coordination network that is also supported by the ATE program. And over here, the idea is basically to create a collective end-to-end innovation ecosystem to lower the barriers for two-year colleges to embrace virtual reality technology to enhance personalized learning. So over here, we do have a group of people from the industry, from academia, from learning sciences, who are providing us input on how well we will be able to develop these virtual reality and AR-based technologies, primarily to be implemented in the actual classrooms. Right now, I guess there's quite a lot of technologies out there. We see that the user acceptance of these technologies are not that great. There are few people who are using it, but there are quite a lot of people who are still working on incorporating some of those things into the classroom settings. So the goal of the coordination network is basically to identify strategies whereby we can lower the barriers for two-year colleges and high schools primarily to use these kind of technologies in the actual classroom settings as such. And our most recent effort is primarily funded by the Department of Defense, and Department of Defense has got a program called the Manufacturing Engineering Education Program, and we were awarded a MEEP grant last year and the year before. The very first grant was looking more in terms of developing augmented reality based systems to support robotics education. And the second one, and that's a collaborative project with MIT, whereby we are looking at building game-based augmented reality and virtual reality-based programs, primarily focusing on photonics. So that's a project that was funded like last year, and we are right now in the process of building quite a lot of virtual reality and augmented reality-based simulations to support photonics education. And we have been doing quite a lot of virtual reality development for industry. We have created virtual reality development modules that are currently being used at AIG, BMW, Lockheed Martin, Boeing, and Honda. There are quite a lot of work that's happening in that particular front as well. So now, as a part of the CA2VES effort and several other projects that we had, in total, we had close to around 143 simulations that were created, right? So this is basically just an example of some of the simulations that we have created. Some of the simulations that we created are procedural in nature, meaning it's talking about the systematic steps that the person needs to take to complete the task. However, even though we have got these many number of simulations, what we identified was that the simulations that are being used by people on an extensive basis are pretty low. Maybe 20 or 30 simulations are used quite extensively by the users, but all other simulations are out there, but they are not extensively used by the people as such, right? So initially, when we started building these kind of simulations, we were creating these simulations primarily based upon the feedback from the subject matter expert. And again, that was helpful, and they provided quite a lot of information, and we created the simulations per their guidance as such, right? However, as we moved forward, we made quite a few changes associated with the virtual reality development process, and we'll talk more about that one in this particular presentation. And so we had 143 simulations in place. Some of them were procedural in nature, and some of them were focusing more in terms of enabling the students get the right kind of skills as such, right? So when we created this particular set of simulations, I believe per the original goal of the CA2VES project, we were required to create quite a lot of virtual reality simulations. However, when we created these visualizations, what we identified was that not a lot of people were just using the simulations. They were like, these simulations are great. However, it would be good for us to have some kind of a wrapper around these virtual reality based simulations. That way we could use this kind of modules as a plug and play system as such, right? So then we basically changed the way how we created these virtual reality simulations, whereby we added video-based lectures, right before the virtual reality simulations, and quite a lot of assessments that were integrated with these virtual reality simulations. And all these things basically formed a module focusing on one specific aspect as such, right? So virtual reality was not standing just by itself. It's basically a module whereby you do have a couple of video-based lectures that talks about the skills and talk about the fundamental science behind that particular simulation. It could be related to a process, or it could be related to an activity. We had a basic video lecture, and we had quite a lot of assessments that were integrated, and all these things formed a module as such. And again, one major challenge that we had was basically the dissemination of this kind of content as such. And many times there were technical colleges or four-year institutions who came to us and said, okay, this is great. However, we are using Canvas as our learning management system, or we are using Blackboard as our learning management system, or we are using Moodle or D2L as our learning management system. Are there ways whereby we could integrate the material that you can develop into our system with ease? That way our instructors could use it without having any major technical barriers as such, right? It was then we thought about maybe building a platform that would enable that kind of a seamless integration, whereby the instructors at two-year colleges will be able to use this one with ease. And so we built the Educate Workforce platform, and it was primarily built using the open edX code base that's provided by MIT and Harvard. However, the system has been customized significantly to support our needs. And right now, all the content that we have hosted on this particular platform can be streamed into any of the learning management systems with ease. That way, the students, when they are experiencing this virtual reality or this kind of content, they basically perceive it to be a course that's offered by that particular class as such. It's part of the learning management system that they see, right? So there are quite a lot of analytics that could be done on that particular platform. And we provide that kind of support to the instructors who would like to see that kind of data for assessment and things of that sort, right? So when you think in terms of virtual reality, the first thing that comes to our mind is basically wearing fancy goggles. You know, you have got heads-up displays and things of that sort, whereby you're using primarily to experience the virtual reality simulation, right? And so initially we followed a very similar track, whereby we had got this hardware intensive virtual reality simulation, where we are using these kind of simulations to focus on one specific aspect. However, from our initial studies, the interviews, the focus groups, and the observational studies that we conducted with the instructors as well as with administrators, and we found out that many a times it might be quite resource intensive for community college, for two-year colleges, and for other institutions to purchase this kind of gear. So they're looking at virtual reality simulations that can be used on a computer, on a normal laptop, you know, that can be connected to the internet, and students would be able to access those things. And that is one need that we still hear, whereby people wanted to have that kind of an experience on a computer that's just connected to the internet. And virtual reality offers quite a lot of potential. However, they wanted to run on a normal computer without having fancy graphics card or anything on those lines as such. So right now we do have quite a lot of entities who are using our content. We do have high schools, community and technical colleges, foreign institutions. There are several state agencies that are using the content, and industry partners as such. And I guess we do have approximately 8,000 users, and there are 323 plus class sections who are using the content that's generated out of this particular effort. So again, now let's change gears a bit. So this is one of the initial training simulation that we created, right? So I'm sure that all of you will know what this particular instrument is. You know, this is basically a vernier caliper, and you basically use vernier caliper to do measurements as such. So this was one of the earliest simulations that we created, focusing on metrology, whereby this particular simulation has got three major phases, right? You do have an introduction, you do have guided practice, and you do have an exercise. So in the introduction section, the basic parts of this particular instrument is showcased to the user, to the student. Then you do have a guided practice, meaning you have got step-by-step instructions that are provided to the students to complete the task. And then finally, you do have an exercise whereby you do have random objects with random dimensions available out there, and students need to measure and enter the values out there, right? So this was one of the initial simulations that we created, right? We created quite a lot of simulations just focusing on how to use a specific instrument as such, right? And so looking back on how we created these particular simulations, right, I would say this was the process flow that we had earlier, right, whereby we were focusing extensively on the SME. SME stands for subject matter experts input, whereby the SME would mention that, okay, it would be good for me to have this kind of a simulation. And we'll be like, absolutely, we can create that one on virtual reality, and we'll go through the process of 3D modeling, developing UV mapping, texturing, building the animation, and we use a technology called Unity 3D primarily to build our virtual reality simulation, and we will integrate all those components using Unity. Then we will build the user interface. Then we do have a quality assurance phase followed by the dissemination phase as such, right? So you could see that we spent very little amount of time with the SME, and quite a lot of time was focused more in terms of building the entire system as such. And again, we all were trained in developing these kind of simulations, and we get most excited, especially when we do have that ability to create these kind of simulations and showcase it to the end users as such, right? However, these kind of simulations were not extensively used by the actual users as such. Even though this particular simulation was created and provided to the end user, we see that there is not a lot of user acceptance of these kind of simulations as such, right? So at that time, we did not worry much about it. We were focusing more in terms of what SMEs needed, and we created quite a lot of simulations associated with that, right? Now let's take a look at a different scenario. So this is basically a scenario for that focuses more in terms of fluid lines and fittings. So this is an activity that is required primarily for FAA Part 147 schools, whereby they need to teach the students on the steps involved in creating the fluid lines and fittings, right? So there are different steps involved with that, and one of the things that the subject matter experts and the instructors mentioned was that it would be good for the students to learn the different steps that are involved in building these fluid lines and fittings prior to them doing an actual experiment, or an actual activity in the lab. So this particular simulation was built primarily to support that kind of a need, whereby this is more in terms of a process-based simulation of an activity whereby they are building these fluid lines and fittings based upon the instructions that are provided out there. And you do have step-by-step instructions. You could see at the bottom part of the simulation that talks about the steps that need to be done. And once they have completed that particular step successfully, then you do have a button called the next step, that gets highlighted in green, and they could go to the next step and complete the activity as such, right? So it's more in terms of explaining or teaching the students the different steps that are involved in building this kind of fluid lines and fittings as such, right? So the good part was that the instructors and the SMEs who were part of this simulation, they really loved the simulation, and they are right now using this particular simulation in their classroom setting. However, we are yet to conduct a controlled experimental study to understand whether this particular simulation has got any effect upon the learning outcomes that the students had. However, based upon the anecdotal feedback that we received from the instructors as well as from the students, they really liked the simulation, and they really enjoyed the ability to do this particular simulation well in advance prior to doing the actual things in the classroom-based settings as such, right? So this is this is a second scenario whereby we spend some time with the SMEs. We try to understand what exactly their problems are, and then build a simulations primarily focusing on the issues that they had in the actual instruction as such, right? And now let's take a look at the third scenario, right? So I believe you could see the kind of ways whereby you could use virtual reality simulations, right? The first one is looking more in terms of how to use an instrument, looking more in terms of vernier calipers and things of that sort, right? And the second one is looking more in terms of a process, right? What is the process that's involved in creating certain things as such, right? And then the next one is focusing more in terms of a process. However, it is looking more in terms on what could potentially go wrong if the students missed a step or something on those lines, right? So I'm sure that you all know what this one is. This is a grinding machine, surface grinding machine. And again, it talks about the different steps that are involved in completing a grinding activity, right? So again, these are all virtual reality simulations, and I'm just showing you a video of what that particular simulation looks like. Over here, the students are interacting with the simulations to complete the task. So this is the guided practice phase whereby students are provided with a set of steps that they need to complete the activity as such, right? So you could see the different kind of steps that they do, and they adjust quite a lot of things, and they complete the task as such. And again, at the end, at the end of this particular simulation, students are given an activity whereby they need to surface grind a block to certain thickness based upon the things that are being provided, right? So in this particular simulation, you could see that this guided practice activity talks about the different steps that are involved. However, I believe that's good for students to know. However, it would be really helpful for the students to understand what happens if they do not complete the steps in the actual order as such, right? And so you could see the modifications that were being made to that particular simulation in this activity, right? So over here, you could see that the simulation that you see on the right-hand side, over here, it talks about the steps. And again, it talks about the kind of things that could happen if they did not follow the steps correctly, right? So the good part about a virtual reality simulation is that I believe you'll be able to simulate what things could go wrong, especially when they do not complete the steps in the right kind of an order. And over here, this is one simple example whereby the student forgot to turn on the magnetic chuck, and again that led to an accident as such, right? So you'll be able to clearly identify the potential things that could go wrong with the system, and students will be able to experience all those things using virtual reality. And what we identified was that that is one good way of portraying quite a lot of things using virtual reality as such, right? So we have been creating quite a lot of these virtual reality simulations, but what is that one lesson that we learned, right? So initially we spent only very minimal amount of time with the actual user, with the SMEs, or with the instructors as such. And in the second set of simulations, we spent some additional time with them. However, we just followed the same process that I explained earlier, whereby you just gathered the input from SME, and we were all excited and thrilled about creating these virtual reality simulations that could be used in a classroom-based setting as such. However, these simulations are used, but again, they are not extensively used by the users, right? And again, what are the issues whereby we are not getting adequate user acceptance of these kind of technologies, right? So there's one question that we had quite a long time, and then we started looking at other disciplines as such, right? There's a famous methodology that was proposed by Ulrich and Eppinger. So Ulrich is a faculty member at MIT, and Eppinger is at Penn, University of Pennsylvania. They basically talk about this particular process whereby you could build products, right? So if you could take a look at what Apple does, what Microsoft does, they basically have got a systematic process whereby they build this kind of products, and you could see the level of user acceptance that they have for their technologies as such, right? So the model that Ulrich and Eppinger proposed was basically called the human-centered design process, whereby they said you need to have an initial mission statement, you need to identify what exactly the customer needs are, then you need to create what we call target specifications, and target specifications are ways whereby you'll be able to quantify the customer needs, whereby you'll be able to ensure that your system will meet those specifications as such. And then they said that you need to create quite a lot of product concepts, and that's where magic will come into play, whereby looking at what customer needs are, and then looking at innovative ways of solving that particular need as such, right? And choose one specific concept to move forward with, test the concept, then set the final specifications and plan for the downstream development as such, right? And they talk about the iterative design, whereby you're not going to create the final curricula or the final system just by building it once. You may probably want to go through multiple iterations, especially using the product concept identification phase as well as testing the product concept phase, to have a system that can be used by people as such, right? So this was a famous method that's proposed by Ulrich and Eppinger, and right now you could see that quite a lot of companies are using this particular system, ranging all the way from Apple to smaller companies, who are just building products and systems to support their needs as such, right? So we basically borrowed some of the principles from the methodology that Ulrich and Eppinger proposed. And you could see that there's a similar kind of a movement that's happening out there. So I guess we have got the Stanford D School, right? And they talk about this particular process called the design thinking process, right? Whereby they say that you need to pay quite a lot of attention to understand what exactly are the user's needs. Try to empathize, try to understand what exactly their needs are. Then you could understand, you could observe, and then you'll be able to come up with this ideation and prototyping phase, whereby you could come up with innovative ways of solving that particular problem, and then you will enter into this phase called storytelling or storyboarding, and then you'll be able to build that final system as such, right? So you could see that it's pretty much similar. The process and the methods are pretty much similar, but I would say the method that's proposed by Ulrich and Eppinger is much more structured, and that's something that we typically use over here at CA2VES primarily to build our simulations as such, right? And there are quite a lot of other things that we could learn from the learning sciences, right? So the learning sciences, they talk about developing effective educational objectives, right? So meaning ask questions, what results are we trying to accomplish? What behaviors are required to accomplish these desired results? and what knowledge, skills, and attitudes are necessary to achieve these desired behaviors, right? So you may probably want to ask all those questions, especially when you're building these kind of simulations. And the most important part would be to build robust assessment methods, meaning you need to ensure that the students clearly learn the skill or the technique that you are explaining using this virtual reality. And over here at Clemson, we do have a multidisciplinary team consisting of instructional designers, learning scientists, and subject matter experts who are providing us input as we build this kind of simulations as such, right? So we looked at other disciplines, we integrated the kind of things that they have provided in their disciplines as such, and then we came up with a modified process flow on how we are creating these simulations. And the slide that you see over here is the modified process flow that we created to build educational material, especially the virtual reality content that we have got access to, right? So over here, it starts with identifying what exactly are the training needs, and we will conduct quite a lot of observational studies, interviews, focus groups with the instructors and the subject matter experts to identify what exactly are they trying to achieve. And then we will establish the educational objectives, and we will define the learning outcomes. And when we define the learning outcomes, we want it to be quantifiable, meaning we should be able to quantify that particular learning outcome at the end of that particular simulation as such, right? And then comes the most important phase, whereby you are generating training concepts, whereby you are looking at multiple ways of presenting that particular information using virtual reality. You are conducting initial studies. We create storyboards to understand what are going to be the steps that are involved. We will develop assessment instruments during that time, and we will test those concepts. And these particular iteration goes multiple times. And once we have identified all the key things and all the nuances associated with virtual reality, then we plan the downstream development, and we follow the systematic process of 3D modeling, UV mapping, texturing, animation, iterative UI development, testing with the users, and integrating with the UI and disseminating the content as such. And so here you could see that we are right now spending quite a lot of time initially identifying what is that virtual reality simulation that is going to create an impact upon the actual users. So it's not all about creating virtual reality simulations or educational content. It's all about creating impactful virtual reality simulations that supports the learning outcomes associated with that particular module. So this is the current process flow that we are using, and we found this particular method to be very effective as we build these kind of simulations. So one common question that we always get is that what are the ways whereby you can identify the training needs? So over here at Clemson, we typically use 4 different methods, primarily to identify what exactly are the needs of the instructor or for the trainer or for the other subject matter experts, especially when they are delivering this content, right? And so what we do is that we conduct observational studies, and these observational studies can be active or passive, meaning we'll be in a classroom understanding what exactly the things that they have taught, or it could be passive, whereby we would remotely observe the way how things are being completed in a lab, and we will use those particular information to document the kind of things that the instructors and the students do in the actual environment. Then we will conduct quite a lot of interviews and focus groups to understand what exactly their needs are. And we use a tool called cognitive task analysis. And again, I will talk about that particular tool in my next slide. And it's one way whereby you'll be able to systematically break down the set of steps that are involved in interacting with the system, and you will be able to identify the cognitive demands and the physical demands that are placed upon the students, especially when they are completing that particular task. And we also use quite a lot of human error identification methods like failure modes effects analysis or systematic human error prediction approach. There are quite a lot of techniques that we use primarily to understand what are the potential errors that the students could make, especially when they are interacting with this system or with this complicated piece of machinery as such. And in the next slide, I do have one example of a task analysis that was done on a standard blood glucose meter. Now, I'm sure that you all know about a blood glucose meter, and this is one example of a task analysis that was conducted for a blood glucose meter, right? So over here, you could see that you do have a major goal of setting up the meter, that is 1.0. And then you do have multiple sub-steps associated with that major task of setting up the meter. Then you do have the second major task of checking the system, and you do have other subtasks associated with that. And you could see that for each and every subtask, that could be 1.1.1 or 1.1.2, you do have task and knowledge requirements that are being outlined. And over here, the task is to press and hold the C button. So the task and knowledge requirements are the location of the C button and the kind of feedback the system provides, right? It could be tactile in nature, it could be auditory in nature, or it could be visual in nature, right? So it talks about the different kinds of feedback the systems provide and the potential problems that are involved out there. And conducting a task analysis really helps us better understand the different steps that are involved when students are interacting with this kind of system, and that will enable us come up with innovative mechanisms of building virtual reality simulations that supports the needs of the actual students as such, right? So we used this new method, the new integrated method, whereby we borrowed quite a lot of information from the other literature, and we do have a few sort of virtual reality simulations that came out of it, right? So this is one of the virtual reality simulations that we created, working closely with BMW, right? So BMW instructors reached out to us and said that we do have quite a lot of issues with safety. So if there are ways whereby you could create a virtual reality simulation that talks about the safety aspects inside a manufacturing plant, that would be helpful, right? And the current way of doing the things is basically using PowerPoint by death, whereby you do have quite a lot of OSHA slides, you go through it, and that's pretty much it, right? And we were looking more in terms of building an engaging experience for the people to learn about the safety violations that can happen in a plant as such, right? So what we did was basically, I believe one potential way to create a virtual reality simulation would be just to have a VR environment where a lot of things are happening out there, and you could talk about the different violations that's happening out there, right? However, in this environment, it's more in terms of a game-based environment whereby students basically assume the role of an auditor, and they walk around the entire system, and there are quite a lot of safety violations happening out there in a random fashion, meaning no two students will see the same violation at the same place. It will be generated completely in a random fashion, and they walk around the entire environment. They do have an iPad in their hand, and they tag the different violations. And we have made a few things quite conspicuous, like, there's some issues with the electrical switch, there are a few things that we have made quite conspicuous, but we do have quite a lot of infotions that are incorporated in this virtual reality simulation, and we do have a database of all these things that are being created, and these violations happen at random places when the students are interacting with this virtual reality simulation. And here you could see that if we could take a look at the process that we explained earlier, when we generated the concepts, we spent quite a lot of time identifying mechanisms to effectively provide this information to the actual users, right? And now let's take a look at this. I'm sorry, let's take a look at the next slide. So this is one of the simulation that was created for AIG, right? AIG, they are an insurance company. So what they do is that they create, they do have quite a lot of field engineers who basically goes to the different buildings, and they assess the risk associated with that particular building, and they develop an underwriter report, that could be used by underwriters to come up with the premiums and things of that sort, right? So in this particular environment, what we have done is that we have followed a similar kind of a process that I explained earlier, whereby we do have a database of all the potential things that could go wrong with an environment, with a warehouse or with a building, and we randomly place those things out there, and students could look into this particular, could go to this particular environment, and they basically go through the similar process whereby they inspect quite a lot of things and generate a report accordingly, right? So if you could take a look at the process that I explained earlier, the issue that the instructors or the AIG trainers had was that, there are quite a lot of new field engineers who are coming out there. However, it would take them at least 2 to 3 years conducting multiple site visits to understand all the potential things that they need to look into. And there are few subtle cues that the expert risk assessor would look into before they write the report. So are there ways whereby you could short circuit this entire process, whereby the new field engineers do have a better understanding on the kind of things that are going on wrong, right? So this particular system has got a database of all the things that we identified, and again, this was done through interviews and focus groups and observational studies with the actual field engineers, and we created all these different violations that are happening out there. And once that taxonomy was built, then we started integrating the taxonomy along with the database of scenarios into this virtual environment. And right now, this is extensively used primarily to train quite a lot of field engineers around the world, right? So this is one virtual reality system that was built that's impactful. And again, the process that we used to build this particular simulation was just like the one that I explained earlier. So creating all these virtual reality simulations are great. However, we need to look at ways whereby you'll be able to assess the efficacy of these kind of simulations as such, right? So we typically use constructs such as the perceived learning outcomes, which basically focuses more in terms of comprehension, memorization, application of learning, analysis of problems, and overview of content. And these are all Likert scale questions that you typically provide to the users to understand the perceived learning outcomes. And it varies from scenario to scenario or module to module, right? And you'll be able to measure engagement. And there's also a Likert scale whereby you'll be able to measure sense of presence, engagement with the activity, and things of that sort. Usability is a major factor, and you'll be able to use the IBM's Computer Systems Usability Questionnaire that was developed by Lewis Jim Lewis as a mechanism for you to assess the usability. And satisfaction perception you'll be able to measure using the technology acceptance model that was created by Davis. And over here, I have provided a reference to some of our work that was published in the Computers in Education Journal by American Society of Engineering Education, where we use some of these metrics primarily to assess the efficacy of the virtual reality simulations as such. However, if you need more information about any of these constructs, please let me know. I'll be more than happy to share the questions and the content that we have focusing on assessment as such. So now to conclude, to wrap up this particular talk, what are the lessons that we learned, working with virtual reality-based systems and developing all these virtual reality systems for more than a decade, right? So the first one is that we need to have a systematic development process. So you need to have a systematic content development process that integrates user-centered design process, system analysis techniques, universal design for learning principles, and relevant frameworks from the educational literature. And we are looking more in terms of, I believe right now, NSF also talks about what we call convergent research, meaning there is a need for multiple disciplines to converge to focus on a problem. And again, that's exactly what we found over here, whereby you need to look at other disciplines and come up with an integrated framework for you to build effective simulations that's going to support the needs of the instructors as well as with the students. The second lesson that we learned was focus extensively on identifying the needs of the actual users. Meaning, do not worry much about creating the virtual reality simulation. Try to understand what exactly the instructors, the students, and the subject matter experts are looking to have, and try to clearly understand and document those things, and then focus more in terms of building the virtual reality experience. The third one is virtual reality and augmented reality environments offer a unique ability to immerse learners in environments that they are studying. However, you need to develop concepts that capitalizes on the capabilities of virtual reality, right? So you could create whatever you want using virtual reality. However, many a times when you create all these things, they may not be as effective as it could be. So try to come up with ways whereby you could generate an innovative concept whereby you could capitalize upon the capabilities, the 3D capabilities or augmented reality-based capabilities of these kind of technologies as such. And our recommendation is not to create just a tutorial or a module just focusing on virtual reality just for the sake of it. Try to come up with concepts whereby you can extensively capitalize upon the capabilities of virtual reality. And the fourth one is to look more in terms of assessing learning outcomes. You need to make sure that you have got appropriate mechanisms whereby you'll be able to assess the student learning outcomes and look at ways whereby you'll be able to increase learner motivation and teach the 21st century's job skills that are required, and look at ways whereby you'll be able to improve the learning. The fifth one that we learned was basically to integrate with other learning material. And that's one common need that we identify from all our industry partners, whereby they mentioned that these virtual reality simulations are great. However, we need to look at ways whereby you could integrate these things with our current material. It could be with our talent management system, or it could be with our learning management system, or it could be looking at the other content that we already have out there, right? So you need to look at potentially integrating virtual reality with other training material in an effective way as such, right? So these are all the lessons that we learned. However, we had quite a lot of challenges, and some of these challenges are still unsolved, right? The first one is device agnosticism, whereby multiple people are using different kinds of operating systems, browsers, and different types of devices like notebooks, tablet PCs, and smartphones. And there's an increasing need from the end users primarily to build these virtual reality simulations that supports a wide variety of operating systems, browsers, and devices. That is still a problem that we are trying to mitigate. Unity 3D provides some solution primarily to tackle this particular challenge. However, the level of interaction or the kind of interaction that the users would need to have in these kind of environments, that is challenging, and quite a lot of work needs to be done in that particular domain as such. The second challenge is effective system level integration, meaning companies would have a talent management system, a training system, a compliance system, and you need to look at ways whereby your virtual reality system would be able to effectively integrate with these other systems as such. And the third part is the use of collaborative VR for training. And Mark did an outstanding presentation 2 weeks back on the capabilities of collaborative VR. And again, one of the major issues that we do have with collaborative VR is that, especially when you do have very complicated geometries associated with the models, it could be quite tricky, for us to render those things in collaborative VR. And again, that's something that Mark and I discussed. So there's a huge push right now on collaborative VR for training, and we need to come up with methods to provide training when trainers and trainees are geographically separated. So there's quite a lot of work right now in the R&D phase, whereby we are looking at the use of augmented reality-based systems, whereby we do have a trainer who is remotely located, and we do have a trainee who is trying to complete an activity, and you do have mechanics like augmented reality-based systems like HoloLens that could provide guidance to the trainees on how to complete that particular task. However, it's quite in the research and development phase, and there's a huge push right now from that particular aspect, focusing on training as well. And there are other challenges associated with assessments, reporting, and tracking, and you need to ensure that these virtual reality simulations provides the ability to create and modify assessments with ease, and you need to use validated methods to assess the trainee's performance as such. And the last one is looking at the ADA compatibility, usability, and security, right? So there's a lot that we could borrow from the human-computer interaction literature. However, there are quite a lot of open issues associated with ADA compatibility, especially when we are developing these virtual reality simulations. For our learning, for our video lectures and things of that sort, we basically provide closed captions as a mechanism for the to support the ADA needs as such. However, from a VR AR standpoint, it's a huge challenge, especially when you're delivering this VR AR content using a browser that can be used on a normal computer. It becomes even more challenging to build effective systems as such. However, there is a need for us to create, borrow, and update the guidelines from HCI literature, and that's still a work in progress. So to conclude, the key takeaway is that it is possible for us to create virtual reality simulations on just about any budget, right? So all we need is basically a small team of developers, and you can create virtual reality sims just about any budget as such. However, virtual reality for training seems to work best when that student is actively engaged in the curriculum. So the interactivity with these virtual reality simulations is going to be the key, and having a systematic process to support the virtual reality development mitigates the major issues that you may have with the user acceptance of these kind of technologies. And that being said, I guess, am I good on time? John?
Yeah, we're good on time. We've got a couple more minutes here, so we'll open it up to the group. I really appreciate that presentation. I think that was a phenomenal overview of all the work that Clemson has done, and actually that's probably an overstatement. I think that's a fraction, but a great snapshot of the work that you've been engaged in and things that I think can really help to meet the current needs as well as the future needs that we're looking at for development of content that'll enhance everything from the classroom to STEM camps and educator workshops. So I guess I won't take up a whole lot of time here. Kind of open it up to the group for any questions that you might have, as I know we're coming up on the top of the hour.
Yeah, thank you for this opportunity, John. I really appreciate it.
Any questions out there from the group? I know with CA2VES being involved in this for quite a while now, over a decade in these developments, I'd be curious on what your thoughts are as you look at how rapidly I think the last 1 to 2 years have really expanded in this space, as far as the technology capabilities for technical education. If you've got any ideas what the next 2 years are going to bring, or the near future, given the current COVID situation, the distance learning thought process, and where that conversation is going in this space.
Yeah, that's a good point, John. I guess so. Right, way back when we started creating the very first virtual reality simulations, I believe if you buy those headsets or this virtual reality hardware, it was in thousands of dollars to buy just one equipment as such. However, you could see that with the development of technologies like HTC Vive, you do have a HoloLens and things of that sort. The cost of this hardware is coming down significantly, meaning more and more people are using it extensively to support their training needs as such, right? So my guess would be that I believe the cost of hardware is going to go down significantly, and we will have more and more virtual reality simulations that would be coming into play. However, we are at this phase whereby when we had the internet boom long time back, you had quite a lot of websites that were created. However, only a few of those websites were quite impactful. So now would be the time whereby quite a lot of virtual reality simulations would be created. However, there could be a few virtual reality simulations or softwares that are going to govern the development of the technology into the future. And I believe that the entities that are going to make that particular difference would have at least one hallmark that would be a systematic system development process. And I could see quite a lot of people who are adopting this technology. In Clemson, quite a lot of people are using it. There are quite a lot of industries who are using this kind of technology. However, it's still right now with the BMWs, with the Lockheed Martins, or with the AIGs in the world, and you need to come up with mechanisms whereby other companies, the small and medium scale companies, will be able to use this one primarily to support their needs as such. And the interesting part is that now the technology is kind of mature, whereby there is no need for you to have sophisticated skills to build the virtual reality simulations. So you could see quite a lot of simulations that are coming out there. If you could focus more in terms of using a systematic process as you build these simulations, you could truly make an impact in that space.
Yeah, lots of really good points there, and great perspective on kind of the transition and advancements that we're currently looking at. I know when we started looking into the VR equipment for some of the aviation simulations back, I think 7, 8 years ago, it was, I think, $20,000 for the Oculus goggles and those type of things that today have become much more economical. And I know this team is really looking at those different opportunities as we think about the participants and audiences for STEM camps and educator workshops and different events, what makes sense and what type of recommendations we should be making based on the experiences that we're trying to create.
Yeah, sure, John. I guess I got Dr. Jeff Bertrand on the call, as well as Dr. Rebecca Hartley. Our team will be more than happy to work with you and your lead and your team, primarily to provide few recommendations as you start incorporating these kind of technologies, in your center.
That sounds great. Is there anyone else? Just last minute questions here. I know we're going past the top. Well, if there are additional follow-up questions following this presentation, definitely feel free to send those my way. If you don't have Kapil's contact information, I'll make sure to get those out to the group. And I know we're looking at trying to put together some different white papers and address some of the questions that have come in from the previous webinars that we've hosted. And I'm sure there's going to be follow-up as the group has time to kind of dig into the discussion points and topics that were covered today. So thank you very much, Kapil, Rebecca, and Jeff, for being here today and providing a great presentation to the group. I look forward to the follow-up. We'll have some upcoming events that dig into video capture techniques. And I'm pulling up a real quick slide here. We'll get this out to the team as well. But video capture techniques, NCAT's currently working on the development of some lab kits on that front, so faculty can capture their activities, whether it's from their home environment, home office, or the classroom environment. So that's something that's going to be coming down the pipe, hoping to get that in another webinar in the next couple of weeks. And then we've also got social media strategies that we'll be talking about for engagement on all these different fronts, and a couple of links there. But knowing we're past the top of the hour, I guess I will leave it there for today's presentation. Again, really appreciate Clemson University and the CA2VES team jumping in today and leading the discussion.